The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I'll respond as soon as I can. All right, so today we're going to start chapter 9. We're going to look at section 9.1, which has to do with radical expressions and radical functions. So let's go ahead and get started. So section 9.1. Let's talk about square roots. Okay. If you have a number, let's say 3, and you square it, you get what's called a perfect square. That is a number that has two identical factors. If you take the square root of a perfect square, you get back to the original number. What does it mean to talk about somebody's roots? It's not talking about their hair necessarily, but talking about their beginnings, where they came from. So 9 is a square that came from 3 being squared. So the square root, in other words, what was the number that was squared to get 9? The square root of 9 is 3. So it's like we're going backwards. In fact, if I had named it, I wouldn't call it the square root, I'd call it the unsquare. So the unsquare of 9 is 3. Now, 3 squared equals 9, but -3, the quantity squared, also equals 9. However, when we go the other direction, we only get the positive, or what is known as the principal square root. Okay. Now, if we take the square root of a number that's a perfect square, we get a nice number. If we take the square root of something that's not a perfect square, we get something that's not nice, and it is irrational, which means it can't be written exactly as an integer or exactly as a decimal or even a repeating decimal. If you put the square root of 8 into your calculator, let's see, I'm going to do that right now and see what I get. Okay, helps if I can see the square root. You got to turn it on first. The square root of 8 is 2.828427125, and then it just keeps going, but it rounded off in the calculator. If I had a calculator that had 1,000 places that it would show, it would still round it off at the end. Okay. Now, if, however, we take the square root of a negative number, we get a number that is not real. Okay. It's imaginary, and we're not going to deal with imaginary numbers at the moment. But suffice it to say, the square root of a perfect square gives you a nice answer, a rational number. So we'll say this is rational. The square root of a number that's not a perfect square, a positive number that's not a perfect square, is irrational. The square root of a negative number is not real. Oh, one more example, the square root of 0 is 0. Any questions about those examples? Okay, so let's take a look at some more examples of that. Let's see, what is the square root of 100? Well, basically you're saying what number squared equals 100? Well, 10 squared equals 100, therefore the square root of 100 is 10. What about the square root of 49? Well, what number squared is 49? 7 squared is 49, so the square root of 49 is 7. How about negative the square root of 64? Well, this thingy here that we'll give a name in just a minute is a grouping symbol. So basically the square root of 64 is 8, and then the negative sign comes outside of it. All right, let's go back and give some names to things. Let's say I've got the square root of 9 again. This is known as the radical, and this is known as the radicand. So the radicand is the quantity that is inside of the radical. Now, right up here, there's no number, But when there's no number there, it's implied that we're taking a square root or a second root. Suppose we have this, the cube root of 8, which would be 2 because 2 cubed is 8. Again, we have the radical, the radicand. This is known, this number is the index. It tells us which root is being taken. When there's no number written in the index, it's an implied 2. Since square roots are the most common roots, mathematicians said, hey, let's be lazy or let's be efficient, and we just won't put an index if it's a 2. So this implies the square root of 4. This would be the cube root of 4, the fourth root of 4, the fifth root of 4, etc. Okay, but again, a radical is a grouping symbol, so you do everything inside before you take the square root or the cube root or whatever. For instance, let's say we've got this. Okay, so the first thing you would do is simplify inside the radical, and then the square root of 16 is 4. Any questions about that? Okay, how about this? The square root of negative 81. Well, as I mentioned earlier, you can't take the square root of a negative number and get a real answer. So this is not real. In fact, let's expand that. You can't take an even root of a negative number and get a real answer. So if the radicand, the number inside is negative, and the index is 2, 4, 6, 8, 10, some even number, even positive number, you can't get a real answer. Okay, so remember that you can't take an even root of a negative number and get a real answer. Also, let's go back here for a minute, and we talked about the principal square root. When you take an even root of a positive number, you get a positive answer. So you can't get a negative answer when you take an even root of a positive number. Okay, so these restrictions have to do with even roots. You can't take an even root of a negative number. When you take an even root of a positive number, you can't get a negative answer. But what about this? Let's see here. What about the cube root of 8? So I'm taking an odd root. Well, the cube root of 8 is 2 because 2 cubed is 8. But what about the cube root of negative 8? Well, that's negative 2 because negative 2 cubed is negative 8. So you can take an odd root of a negative number. You just can't take an even root. And you can get a negative answer when you take an odd root. So again, the restrictions have to do with even roots. One more time. You can't take an even root of a negative number and get a real answer. When you take an even root of a positive number, you can't get a negative answer. Okay, now, what about this? It says use a calculator to find each square root, the square root of 12. All right. So I don't know about your calculator, but I have the TI, what is it? The TI-30X, Roman numeral 2, S for solar. And it says use a calculator to find each square root, give answer to 4 decimal places. So on my calculator, the square root is a second function of the x squared key, which is right about in there. So I'm pushed second, and when I second and then the square root button, I get this. So I'm going to put the number 12 in there, close it up and push equals. And I get 3.464101615. It said round to 4 decimal places, so that would be right there. The 0 would round down, so 3.4641 would be the answer. Any questions about that? Okay, let's see here. Let's do one more. Let's do the square root of 0.0063. So second square root 0.0063, close it up. I get 0.079372539, 4 decimal places. The 7 would round up, so 0.0794. Okay. Now, you need to be careful because on your calculator, at least on the TI-30X2, there's this button that's an x squared, and the second function key is a square root, okay? Then right above it, there's a button that looks like a little caret, and it looks like that. And the second function of that has an x in the index, the xth root. You don't want to use that when you're trying to take the square root, okay? And we'll talk more about that here in a minute, okay, or 2 or 3. Now, this says, simplify each expression, assume that all variables are unrestricted. So that means if there's a variable inside of a radical, we cannot assume that it's positive or that it's 0. We have to assume that it could be positive or 0 or negative, any of those things, okay? And use absolute value symbols when necessary. How does that work? Okay. Let's say we have the square root of 4x squared, okay? And they say that x is unrestricted. So x could be positive, x could be negative, x could be 0, x could be any real number, okay? Well, the square root of 4 would be 2, right? And you'd think the square root of x squared would be x, except there's a problem. Remember I said that when you take an even root, you can't get a negative answer. And since x is unrestricted, we don't know if x is positive or 0 or negative. So what we have to do is put absolute value bars around the x that assures us that 2x is not a negative answer, okay? Any questions about that? This is a little bit of a tricky thing for people to get used to. All right, now let's take a look at another example. Let's say we've got the square root of 81h to the 4th power. The square root of 81 is 9. The square root of h to the 4th power, in other words, what times what would be h to the 4th power? It would be h squared times h squared. In other words, what times itself? So this would be 9h squared. But wait a minute, we're taking an even root, so we've got to make sure that the answer isn't negative. But consider this. Let's say that h is positive. What's positive squared? That's positive. That's safe. What's 0 squared? That's 0. 9 times 0, that's not negative. What if h is negative? What's a negative number times a negative number? That would be a positive number. So for this answer, I don't need absolute value bars because h squared, where h is any real number, could not be negative. How we doing? Starting to get a headache? Okay. What about this one? What about the square root of 36x to the 6th power? Okay. Well, the square root of 36 is 6. The square root of x to the 6th would be x cubed. Do I need absolute value bars here? Yes, I do, because if x is a negative number cubed would still be negative. So I need absolute value bars to make sure I'm not taking an even root and getting a negative answer. And finally, how about this one? The square root of 144m to the 8th power. That would be 12m to the 4th. M to the 4th wouldn't be negative because taking a negative number to an even power, it's going to be positive. So again, I don't need absolute value bars here. Okay. Again, all of those, it said the variables were unrestricted. Sometimes it'll say, assume the variables are positive, and then we don't have to worry about absolute value bars. Okay, how about this one? The square root of b squared minus 14b plus 49. And again, assume all variables are unrestricted. Well, we can't break up a sum or a difference inside of a radical. If there's a product, we can break it apart, and we'll look at that more later. But I have to deal with this whole thing as a single quantity, but I can do this. I can factor this into that because it's a perfect square trinomial. Well, the square root of a square is going to be the base inside, b minus 7. But now, again, we still have those same restrictions or lack of restrictions that says the variables are unrestricted. Since b could be a positive or a negative number, we can't have an answer that's negative because we're taking an even root. So we need absolute value bars. Okay. Let's see here. How about this one? Go back up here. Graph, and it says, complete each table and then graph the function. It says f of x equals the square root of x. Okay. Let's see. For this particular problem, they already have the x values. Why do you think they use 0, 1, 4, 9, and 16 for x values? Because those are perfect squares. And if x is a perfect square and you take the square root of the perfect square, you get a nice number. So if x is 0, the square root of 0 is 0. If x is 1, the square root of 1 is 1. If x is 4, the square root of 4 is 2. If x is 9, the square root of 9 is 3. And if x is 16, the square root of 16 is 4. So graphing this, I've got what? 0, 0, 1, 1, 4, 2. And then it goes off the graph, but my graph is going to look like this. And it's going to continue on like that. Okay. Any questions about that graph? Let me ask you this. What is the domain of this function based on the graph? Can x be negative? No, you can't take an even root of a negative number and it doesn't show up on the graph as negative anyway. It's 0 to infinity. Any questions about that? What about the range? Well, the range is also 0 to infinity. So the range here and the domain there, okay? In fact, everything's in the first quadrant except for 0, 0, which is at the origin. But so your domain is greater than or equal to 0, your range is greater than or equal to 0. Remember, you can't take an even root of a negative number. And when you're taking an even root, you can't get a negative answer. So that just kind of confirms that. Any questions about that problem? Okay, let's take a look at one more of those. F of x equals the square root of x plus 2. Now the 2 is not inside the radical. It's a whole separate term. And again, they have this table. 0, 1, 4, 9, 16. So we're going to put x in the x value in the place of x, take the square root, and then add 2. So f of 0 would be the square root of 0 plus 2, which is 0 plus 2, which is 2. F of 1 would be the square root of 1 plus 2, which is 1 plus 2, which is 3. F of 4 would be the square root of 4 plus 2, which is 2 plus 2, which is 4. F of 9 is the square root of 9 plus 2, which is 3 plus 2, which is 5. And f of 16 is the square root of 16 plus 2, which is 4 plus 2, which is 6. Okay, so we've got what? 0, 2, 1, 3, 4, 4, and then again it goes off the graph. And what's the domain of this? Well, it's still from 0 to infinity, but what about the range? The lowest range value is a 2, isn't it? So 2 to infinity. How does this graph differ from that graph? If we take this and then we add 2 out at the end, wouldn't that move everything up 2 units, which is exactly what happens there. So we have what's known as a vertical shift up 2 units. Okay, now let's see here. Let's take a look at this. It says graph each function, give the domain and range. F of x equals the square root of x plus 4. So now the 4 is inside of the radical. It's part of the radicand. Well, on our previous examples, the only thing inside the radical was just x. So if x was a perfect square and we took the square root, we got a nice number. But now we're going to have x plus 4. So we want x plus 4 to be a perfect square. Okay. So it's like we want x plus 4 to be 0, x plus 4 to equal 1, x plus 4 to equal 4, x plus 4 to equal 9, x plus 4 to equal 16, okay? Because we want the radicand to be a perfect square. Well, if x plus 4 equals 0, x would have to be what? Negative 4. If x plus 4 equals 1, x would be, let's see, what would that be? Negative 4, negative x would be negative 3. If x plus 4 is 4, x would be 0. If x plus 4 is 9, x would be 5. And if x plus 4 is 16, x would be 12. So what have I done? I've chosen x values where that value plus 4 is a perfect square. So then when I take the square root of the perfect square, I get a nice number. So watch closely. F of negative 4 equals the square root of negative 4 plus 4, which is the square root of 0, which is 0. Okay. F of negative 3 equals the square root of negative 3 plus 4, which is the square root of 1, which is 1. F of 0 equals the square root of 0 plus 4, which is the square root of 4, which is 2. F of 5 equals the square root of 5 plus 4, which is the square root of 9, which is 3. And F of 12 is the square root of 12 plus 4, equals the square root of 16, equals 4. Okay, so basically I took perfect squares and subtracted 4 so that when I add 4 inside, it goes back to being a perfect square. What does this graph look like? Let's see, negative 4, 0, negative 3, 1, 0, 2, 5, 3. How does that compare to that? It's moved this way 4 units. Interesting. What's the domain of this? It would be what, from negative 4 to infinity, and the range would be from 0 to infinity. Okay. Next set of questions. And again, if you have any questions, please interrupt me or say something or whatever. This says find the domain of each function. F of x equals the square root of x plus 6. Well, we don't need to graph it. Consider this. The radicand, that is the quantity inside, can't be negative because you can't take square root or even root of a negative number. So that means the radicand has to either be greater than or equal to 0. Greater than 0 would make it positive. Equal to 0 would make it 0. But what have we left out of that? Negative numbers. X plus 6 can't be negative. So it's got to be positive or 0. Well, to solve this thing for x, we get x greater than or equal to negative 6. So your domain would be -6 to infinity. Any questions about that? All right, here's another one. H of x equals the square root of 35 minus 5x. They want to know the domain of the function, so the radicand has to be greater than or equal to 0. I'm going to subtract 35, -5x greater than or equal to -35. Let's do a better job of that. Divide both sides by -5. Oh, but what happens when you multiply or divide both sides of an inequality statement by a negative number? You change the direction of the sign. So the domain would be what? -infinity up to and including 7. All right with that? Okay. Now, this says find each function value. So we've got f of x equals the square root of 3x plus 1. They want us to find f of 8 and f of -2. F of 8 would be the square root of 3 times 8 plus 1, which is the square root of 24 plus 1, which is the square root of 25, which is 5. F of -2 would be the square root of 3 times -2 plus 1, which is the square root of -6 plus 1, which is the square root of -5, which is not real. Okay. Let's see here. This says use a calculator to find each function value. F of x equals the square root of x squared plus 1, and they want f of 4. So that would be the square root of 4 squared plus 1, which is the square root of 16 plus 1, which is the square root of 17. So we're going to take the square root of 17. So square root of 17. And it says round to the nearest 10,000. So I get 4.123105626 tenths, hundreds, thousands, 10,000. So again, it's 4 decimal places. The 5th place would round down. So 4.1231 would be the final answer. Questions on that? All righty, we'll just keep going then. This says simplify each cube root. What's the cube root of 1? Well, it's 1 because 1 cubed is 1. What's the cube root of 8? Well, it's 2 because 2 cubed is 8. What's the cube root of -27? Well, it's -3 because -3 cubed is -27. How could you use a calculator? In fact, let's do this. Let's take, there's a problem that says the cube root of 1,000, which would be 10 because 10 cubed is 1,000. Okay. Remember earlier I talked about there was that symbol that was a second function key, and above it there was that one. So we're going to use the X root button, okay, where the index is the X. But what you have to do on your calculator, at least on the TI-30X2, is you put the index in first. So if I want the cube root of 1,000, with my calculator cleared, I type in a 3, then I type the second and the X root button, so second X root button. So now I have that. I put in the 1,000, and then I push equals. And I get 10, okay? Now in my calculator, when I push this button, it gives me a parenthesis. When I push this button, it does not give me a parenthesis. So you'll have to decide whether you need a parenthesis or not, depending on what you're putting in. If you're just putting in a single quantity, you don't need parentheses, okay? Now, What about this situation? The cube root of 8 over 27. Cube root of 8 over 27. Okay. When we have a fraction inside of a radical like this, we can separate the numerator from the denominator in this fashion. And we'll talk more about this specifically in a later section. But so if I've got a fraction inside, I can separate the root of the numerator divided by the root of the denominator. The cube root of 8 is 2. The cube root of 27 is 3. So the cube root of 8 over 27 is 2/3. How about this one? The cube root of 125 over 64. So that would be the cube root of 125 over the cube root of 64, which is 5/4. Okay. Any questions there? How about this one? The cube root of negative 512 x cubed. Let's see, the cube root of negative 512, I could use my calculator on that. I could go put in a 3 and then second the x root of negative 512, okay, which is negative 8. And then what's the cube root of x cubed? It's x. Do I need absolute value bars? No, I'm taking an odd root, so x could be positive or negative or 0, and it wouldn't matter. Okay. How about this one? The cube root of negative 343, a to the 6th, b cubed. Well, again, let's see, the cube root of negative 343. So 3 second x root of negative 343. Oh, that's negative 7. What's the cube root of a to the 6th? Well, a squared times a squared times a squared would be a to the 6th. So the cube root of a to the 6th is a squared, and the cube root of b cubed is b. Once again, I don't need absolute value bars because I'm taking an odd root. Any questions there? All right. Let's see here. I am going to close this up and open it up again. Sorry, so that I can go back and use my graphs again. Okay. Sorry, my phone's buzzing. I'll move it out of the way. This says complete the table and then graph the function. So we've got f of x equals the cube root of x. So now they have the following x values. Why did they choose those? Because those are perfect cubes. When you take the cube root of a perfect cube, you get a nice value. F of negative 8 equals the cube root of negative 8, which is negative 2. F of negative 1 equals the cube root of negative 1, which is negative 1. F of 0 equals the cube root of 0, which is 0. F of 1 is the cube root of 1, which is 1. And f of 8 is the cube root of 8, which is 2. Let's see, negative 8, negative 2, I can't put on this graph, but negative 1 I can, and 0, 0 I can, and 1, 1 I can, and 8, 2. Tell you what, let's kind of stretch it out. Let's say 5, 6, this is 6, 7, so 8 would be about here. So 8, negative 8, negative 2 is about there. 5, 6, 7, 8, positive 2 is about there. What we get is a picture that looks like that. Erase the whole thing. Okay, so that's a cube root. What's the domain of that thing? Would be all real numbers, and the range would also be all real numbers. Because as this thing is going to the right, it's going up. So it's going over to positive infinity in terms of x, up to positive infinity in terms of y. As this goes to the left, it's going down. So again, negative infinity in terms of x and y. Okay, let's see here. This says evaluate each radical expression if possible without using a calculator. The sixth root of 64. Well, 64 is 8 times 8, which is 2 times 2 times 2 times 2 times 2 times 2, which is 2 to the 6th power, right? So if I break it down into its prime factors, 64 is 2 to the 6th power. Well, what's the sixth root of 2 to the 6th? If you take the root matching the, if the index, I should say, or the root, matching the exponent inside, if the base is positive, they undo each other. So the sixth root of 2 to the 6th power is 2. In general, you could say the nth root of a to the nth power equals a if n is greater than 0. So if the base, excuse me, that's not what I meant to say. If a is greater than 0, my bad, okay? So if your base is positive and the index matches the inside exponent, they sort of undo each other, and we'll talk more about that in a later section. But the nth root of a to the n is a if a is greater than 0. So let's see, how about this? Well, negative 27 could be written as negative 3 cubed. Now here, the base is not positive, but because we're taking an odd root, it still works, okay? So the cube root of negative 3, the quantity cubed, is negative 3. But we have to be careful with that. Let's see here. What about this? The fourth root of negative outside 625, okay? 625 is 25 times 25, which is 5 times 5 times 5 times 5, which is 5 to the 4th power. Now, the fourth root of 5 to the 5th, 5 to the 4th rather, is 5, but then outside the negative sign hits it. We're getting a negative answer, but that's after we took the fourth root, okay? So again, taking an even root, the inside, the radicand can't be negative, but there can be a negative sign outside after the fact. Okay, let's see here. How are we doing? We still got a couple of minutes. It says simplify each radical expression, assume all variables are unrestricted. The fifth root of negative 32x to the 5th. Well, negative 32, let's see, that would be negative 2 times negative 2 times negative 2 times negative 2 times negative 2, isn't it? 2, 4, 8, 16, 32, negative times negative times negative times negative times negative is positive. So it'd be negative 2. But then the fifth root of x to the 5th is x. Do I need absolute value bars? No, because it's an odd root. You only have to be careful when you're taking an even root. How about this? The 8th root of t to the 8th power. Again, all variables are unrestricted. Well, the 8th root of t to the 8th would be t, but since we don't know if t is positive or negative or 0, and we're taking an even root, we have to protect it with absolute value bars. How about this one? The 6th root of negative 729. Well, we're taking an even root. You can't take an even root of a negative number, so this is not real. Okay. Let's see. How about this one? The 4th root of x minus 7 to the 8th power. Again, variables are unrestricted. Well, this would be what? X minus 7 squared And I don't need absolute value bars because if x minus 7 is negative or 0, squaring it, it's not going to be negative. So I don't need absolute value bars there. What if I had this problem? Again, things being unrestricted there, I would need absolute value bars, okay? But since you're squaring this, it wouldn't have a final answer that's negative. Okay, take a look at this. These are called lookalikes. The square root of 64 is 8, right? Because 8 times 8 is 64. The cube root of 64 is 4, because 4 times 4 is 16, times 4 is 64. The square root of negative 64 is not real, because you can't take an even root of a negative number. The cube root of negative 64 would be negative 4, because negative 4 times negative 4 times negative 4 is negative 64, and you can take an odd root of a negative number. Well, I think I've pounded on your brains enough for today. So for tonight, you've got section 9.1. I will be back this afternoon at 1:15 with an office hour. I'm going to go ahead and stop the recording.